Hey guys, my name is Joe Piezinski. I'm with Advanced Innovations here in Austin, Texas, and I'm going to post a video that's going to change your life if you've ever had to single point thread on an engine lathe. This is an engine lathe, and I think if you've run this machine a few times, you're familiar with the dials, the screws, the half nuts, some of the controls. Naturally, you have controls that you use for threading. You have controls that you use for turning, facing, on, off, reverse. I'm going to show you some basics today. I'm going to show you a trick that is probably going to change the way you think about single point threading. Okay, first and foremost, 99% of the videos that I've watched online show the operator of this particular machine threading towards the headstock. Now when you do that, you stand here with your nerves all on edge because it's a very narrow margin of okay, disengage that half nut and stop the thread. You can't use a stop when you thread because a half nut engagement is different than the engagement that you use for turning or facing. Sometimes you have a clutch, you can adjust the tension, and when your carriage bumps up against your stop, the clutch kicks in and everything just stops and everything is fine. But if you try that with a half nut when you're threading and you set a positive stop and your carriage runs into that stop, you usually shear the pin off on the lead screw, potentially wreck the part, break the tool, and then you got to go and tell the boss that you just messed up his machine, which doesn't usually end well. So I'm going to show you how to avoid that. This is a trick I learned a long time ago, and let's get to it. Okay, first and foremost, I'm going to say that a lot, so get used to it. This little guy right here is the clock dial that you use when you're threading. Now mine is engaged because this unit here can pivot in and out, so you don't have to have it consistently wearing on your lead screw. But you can see as it turns, the numbers, the dash marks all come around. You can use whatever index point you want, provided it's in relation to the factory set there. I have a little magic marker line up here that I use because it's just easier for me to see. Now if you're running an odd number thread, an odd pitch thread, you can use a numbered line only. If you're using an even pitch thread, you can use any of them, but beware that the nut will engage on the half. So if you miss your line when you go for it, that's not going to be very pretty. You're going to have what's called a half thread, and you're going to turn a 10 pitch thread into a 20 pitch thread, and it's going to look pretty ugly. Anyway, okay, normally when you thread into the headstock, and I don't know if I'm going to be able to do this easily, but I'm going to give it my best shot. I'm going to use two threads today, two different tools. First tool is going to give us the undercut. And if you ever watch a video on a guy running an engine lathe and he's wearing jewelry, ring, watch, long sleeves, tie, long hair, or no glasses, click on the thumbs down and turn them off. Okay? Safety first. I like to start with the undercut in the part. I know where everything is, and I actually have a physical stop set that I'm going to thread with. And if you guys have ever run a thread, you're going to say, man, this is really not cool. The window of opportunity to stop that carriage is really small, and you're absolutely right. Doing this is not a good idea if you're doing it the old-fashioned way. But watch this trick. I'm going to go to 0 on my digital. It's just so that the undercut tool comes in, gets down in the undercut, gives us a nice little cleanup, and back out. This is insert tooling. This is K68 inserts, positive rake. You don't want to use a negative or a flat rake on aluminum, brass, plastic, because all it's going to do is drag, increase the tool load, and probably snap the tool. All right, now here comes the ankle biter, or the nail biter. My technique, we're going to use the same kind of insert tool, but only this tool, as you can see, is mounted upside down. There you go, upside down. Well, I guess you can imagine what's going to happen next. If you've never set up an engine lathe to run a thread, if the spindle is turning in the same direction as your lead screw, you have a right-hand thread. It doesn't matter if it's running forward, reverse, or what. If the spindle rotation is the same as the lead screw rotation, it's a right-hand thread. If they're opposite, if they're turning into each other like an old clothes dryer, like a pinch press or a feeder mechanism of some kind, then you're running a left-hand thread, okay? Same direction, right hand, different direction, left hand. Check this out. I'm putting this machine in reverse for this particular thread. Tool is on center, upside down, running it into the stop. I always like to adjust my hand wheel so that it's on the downside of the weight, so that if there is any slop in the carriage and it decides to move, the weight of the hand wheel is going to keep it against the stop. This is where you would normally be squinting and clamping your butt cheeks together as the tool is approaching the undercut, because you have about a nanosecond to disengage the half nut and stop the thread. Well, check this out. Crack my knuckles, check the watch that's not on my hand, see what time it is. Oh yeah, I think I'll shut the carriage off. There you go, no panic. Boom, thread. It's the first pass, and with any kind of thread you can run a deep pass on the first pass because you're using the least amount of your tool at this point. The tip is you want to keep it buried if you're using carbide so you don't snap it off. Okay? Most guys are going to say set this at 15, 30, whatever. If you're plunging with carbide, go straight in. It doesn't matter what this is set at. I'm on 23. I'm going to back it out. I'm going to go back to my stop. Back into reverse. Tool's going back in the undercut. This is going to make some noise. 65. Off, still moving, no panic, no nothing. Okay, now I'll shut it off. I could run the complete thread here and waste a whole bunch of YouTube time, but you got to get the idea. And if anything goes wrong with this tool, if the tool load is excessive on this tool, I'm going to loosen up on the Aloris post. If anything gets excessive with the load on an inverted tool, it lifts. It doesn't snap off, it lifts. Okay? Also a good way to run a huge form tool upside down. It works really well. Okay, let's see that one more time. And you don't have to shut the machine off in between. I'm just doing that so you can hear the video. Take a look. Right now you can see the little chatter marks in there. That's just because of the depth of the cut. I'm going to go with a little bit less depth on this one. I'm going to go to 85 on this one. You can use any of these lines. Remember, because this is an even number thread. This is a 10 thread. You can see them coming around. Pick whatever one you want. It's kind of hard to do with one hand because I like to maintain a little bit of pressure on my hand wheel when I do this to take the slop out of the thread, in case there's any wear in your lead screw. So I'm going to put the camera down one more time. It's off, still moving. Look how easy that was. That is the best trick there is for running a single point thread on an engine lathe. If you need to go to an undercut, invert the tool, start at the undercut, and pull out. I could run this all the way down to the root diameter, but that would serve no purpose. All right, I just watched a video online where a guy used the nut as a gauge. Good idea if you're only going to use that thread with that nut. But if that nut wears out and you go get another nut and it doesn't fit, then what are you going to do? So it's easier to have the correct size thread. Don't use a nut as a gauge. These are called pitch wires. Inside this set, bunch of different size diameter wires. They're all labeled. There's 3 of them. The pitch chart right here, these are from a company called PD, which is also an acronym for pitch diameter. Look for what thread you have, what threads you're turning, how many threads per inch. It gives you the wire size to use. The add number is the number that you add to the nominal diameter of the thread. So if we're running a 1-inch 10, so to speak, the pitch diameter would be 1-inch 013 and change, if you're not looking for a gauge thread. But if you're looking for an accurate thread, use the constant in conjunction with the pitch diameter from your machinist handbook, and make sure you're looking at the right A or B class thread. Best way to remember what an A class or a B class thread is: an A thread is exposed to the air, so that's an external thread. A B thread is down inside of a bore, so it's an internal thread. A, B, easy to remember. A, air, B, bore. Okay? There's your 10. Back to the pitch chart. It says 055 diameter wires. I'm going to find the 55 diameter wires in there right here, because it says so. Now, if I had 4 hands, I would actually mic these up and make sure that I'm using 055 wires, but since these are my wires, I know they're 055s. When you use a pitch wire, a 3-wire measurement for checking a thread, you put 2 wires on one side of the thread and 1 wire on the other side, and then you go over the top of it with a micrometer. Now this is going to be kind of hard to hold, so let's see if I can pull this off for you. Okay, now if you see the front wire, the single wire is in the same track as the back wire, and the double wire on the back side is just the next one over. Now all you would do is put a micrometer over the 3 sets and come up with a dimension, and based on what the constant is in your chart, you subtract that, look at the value that you're supposed to have from your machinist handbook, and make your adjustment accordingly. You'll come out with a gauge perfect thread every time, guaranteed. So get yourself a set of these wires, get one of these charts. If you don't have a machinist handbook, it's about 3 inches thick, costs about 60 bucks. And us old timers, we call it the Bible, so get one of those too. Okay guys, upside down tool, thread out, machine in reverse. You can increase the RPMs of the spindle, because it's not a matter of coordination and timing to shut down your carriage and disengage your half nut. The tool ends up off the part. It's a lot easier, a lot faster, and if you try it, you'll like it. Leave me a comment below. I hope you like this. Good luck. Try it. See ya.